Trend Micro Artifact Scanner, TMAS, performs pre-runtime vulnerability and malware scans on artifacts. The scanner can find vulnerabilities on this operating systems and can find vulnerabilities in the code written using the following programming languages shown on this page. TMAS can be integrated into your continuous integration or continuous delivery pipeline. For example, Jenkins projects can automatically build, test, and push Docker images to a Docker registry. Once pushed, the image may be instantly available to run in an orchestration environment. If open-source vulnerabilities exist in the image, then they are a risk when the image is run. Since images are intended to be immutable, images should be scanned before they are deployed to a cluster. Here are the system requirements for TMAS application, and all you need is outbound port 443 open to reach Trend Micro Cloud. So let's install the app on our Linux machine. We just need to copy the link and get it download and untar to local file system. Let's open an README file to see what should be done next. So we need to add the binary folder to the path, but I will simply move it to existing folder that is in path variable. The next step, we must obtain the API key from our Vision 1 console. For that, we firstly need to create a role with appropriate permission to run scans. After that, We will export the API key into system variables and run the scan with the -TMAS scan command. And wait for result. So in the output, we got the JSON with the scan results. With that, we can parse and take decision with our CI/CD automation. Container security provides policy-based deployment control through a native integration with Kubernetes to ensure the Kubernetes deployments you run in your production environment are safe. So here I have a small Kubernetes cluster, just with one worker pod. And we have container security already deployed. You need a Helm deployment file to deploy container security, but we will do a step back and uninstall this deployment, and then add it back with Vision 1 console. You can delete all of the resources created by a Helm chart using Helm's uninstall command. Use the Helm list-all namespaces command to list installed releases in all namespaces. If you created a Trend Microsystem namespace during install and do not have any other components in the Trend Microsystem namespace, you can delete the namespace by running kubectl delete namespace Trend Microsystem. By default, Container Security Continuous Compliance creates a Kubernetes network policy for you. The created network policies is not be removed, even if the chart is uninstalled. To remove these policies, run kubectl delete network policy lapp.kubernetes.io instance trend micro, all namespaces. Next, we will remove all custom clusters from our Vision 1 console. And we will add again this cluster, specifying its name policy and protection parameters. On the next step, we must copy and update the overrides.yaml file. Notice that this file will be shown only once, and make a deployment using provided Helm command. Let's check out pods. Go back to console and wait before the protection status is on. Protection status is ready on our single pod. Next step, you can modify your policy depending on your needs. So to conclude, container security is a security solution for your containers at all stages of their life cycle. At deployment, policy-based deployment control ensures that container images are run only when they meet the security criteria that you define. After deployment, continuous compliance allows you to intermittently scan your containers after they are deployed. At runtime, runtime security provides visibility into any container activity that violates a customizable set of rules.